Hello everybody, welcome to the course that reactive intermediates carbene and nitrene. Here we are studying now various type of reactions of the reactive intermediate carbene species. We have studied its addition reactions and after that we are continuing with the different type of insertion reactions. In the last class we have studied that how a carbon hydrogen bond that can be inserted into a carbene species. We have understood that how this carbon hydrogen bond from various type of electronic nature can be inserted into the carbene species through concerted manner. Today we will discuss that the generation and reactions of ylides by carbenoid decomposition. So, additionally we will understand that different type of hetero atoms or the different type of nucleophiles, how they can insert into a carbene species. As per example, when there is a carbonyl group or any other nucleophilic functional group that is near to the carbenoid carbon, then that can nicely react to give certain intermediate by intramolecular bonding. Okay. So, overall what will form that obviously these type of reactions can be intramolecular or intermolecular, but what will form that the heteroatom that can nicely interact or that can react to the electron deficient carbene species. Okay. As per example, if we see the carbonyl ylide formation. Okay. So, the carbonyl group if we see, okay. So, these oxygens they are having this lone pair. Now, if we take the corresponding diazo compounds, now in presence of different transition metals, what it will do that these diazo compounds they can nicely form the carbenoid species. Okay. And once it will generate the carbenoid species, so the from the carbonyl group that oxygen which is nucleophilic now that can react to this electrophilic center of this carbenoid and give this type of system. Okay. Now, once it will form, now this ylide that can now react with different way. As per example, if there is any double bond, this can give the cycloaddition, give this type of product, or it can give by this type of product, okay, or it can give. So, this can react over here and this oxygen can from this double bond this it can come. So, overall it can give the corresponding epoxide product. Okay. So, there are various way that it can proceed. Okay. So, like here it is going for cycloadditions and in this case it can goes like this hydrogen can come and this bond can come out over here. Okay. So, it can give this type of olefin or even these negative charge that can react over here and then it can give the corresponding epoxide. Okay. So, if we see now few examples of this type of carbonyl ylide, how they behave under this type of transition metal catalyst to provide these metallocarbenes and how they proceed. Okay. So, as per example, if we take this substrate as the carbene precursor, this diazo compound we have taken. Now, if there is this ester moiety, okay, which is having this olefin, this is important. Okay. So, now in presence of rhodium 2, here it is rhodium 2 acetate. Okay. So, this will generate the metallocarbene. Okay. So, once you have generated this, then you have this oxygen lone pair over here, okay. So, that can react over here, and once it will react over here, then obviously that will form the ylide, okay. So, and write in this way, this is the negative, here it is positive. Okay. Now, you see this is nicely placed for 3+2 cycloaddition. This ylide is there and this olefin is there. So, it can go this 1,3 dipolar cycloaddition, okay, to give this fused product. Okay. So, what we have generated? We have generated these metallocarbenes from this diazo keto compound, which is having this ester moiety with the olefinic part, and in presence of rhodium 2 acetate, this will generate this carbenoid species, and once it has generated the carbenoid, it is having this oxygen with some lone pairs, and this oxygen now this is nucleophilic enough to react or to attack to this electrophilic center. Once it will react, it will give this ylide, and once this ylide will form, this can react with the corresponding olefin to provide this product. Next, we will see another similar type of reactions, where in spite of taking the olefin as intramolecular way, we will take that alkyne for the corresponding dianophile to do such kind of reactions. Okay. So, what we will take? We will take the corresponding diazo compound as the carbene precursor, okay. And now, we have this lactone moiety with it, and if we have this in presence of again rhodium 2 acetate, and we have this alkyne with us. Now, this alkyne can react with the corresponding ylide in intermolecular way. Okay. So, now if we treat this with rhodium 2, first what it will generate? Okay. So, now this oxygen is nucleophilic enough to react over here. Okay. So, to provide the corresponding halide. Okay. And we have now this alkyne as a dianophile. Okay. Now, this alkyne, so it can react through this, again 3 plus 2 cycloaddition reactions can happen and give the final product. Okay. So, we will get this fused product as the final product in this particular reaction. One interesting reactions where the halide formations followed by the sigmatropic rearrangement will happen, that we will see now. For example, if we take this ether as the starting material with the corresponding diazo compound as the carbene precursor. Okay. So, now we have taken the rhodium 2 acetate as the catalyst, and what it will form, this oxygen lone pair here, it is nucleophilic enough to react to the corresponding metallocarbene center, and once this after this electrophilic carbon center where it will react after formations of this metallocarbene. So, this will generate Okay. Now, this halide, this is ready to attack the for the further 2-3 sigmatropic rearrangement. So, what is this is 1, 2, 3. Okay. So, now 1, 2. So, if we see now this can attack over here, this is, and this bond can, sigma bond can break. Okay. So, this is the 2-3 sigmatropic rearrangement, because the sigma bond that is forming through 2 and 3, and what is breaking, from there we have started the counting, that is 1 here, that is 1. So, this bond that is breaking over here and the new bond forming through here and here. Is it clear? Okay. So, if it forms these, or if it goes via this 2-3 sigmatropic rearrangement, then the product will be okay. So, then the product, final product will be the insertions followed by the sigmatropic rearranged product, that is nothing but this product. Okay. Next, we will see in another example where similar type of concept has been used to get a advanced intermediate for the natural product gambieric acid. So, we will see that here R is the silyl group, some protecting group which can protect the corresponding hydroxyl group. Okay. So, now again here this oxygen that is having the corresponding lone pairs. So, after formations of this metallocarbene, here they have used copper 2 salt as the metal catalyst for generations of these carbenoid species, and once it will generate. So, this will form okay. So, and this one will be the negative. Okay. So, now again we will make 1 2 3 1 2 3 and here also 1 2. So, here what we have, we will see that this sigma bond will break and the new sigma bond will form between these two. Okay. So, now if we see that how this rearrangement will happen. So, it can attack over here, then okay. Okay. So, finally, the 2 3 sigma tropic rearranged product will form here also. Okay. To provide the key intermediate of the natural product gambieric acid. Okay. So, this is the major product and this is the A ring fragment. Okay. So, overall all these cases we have seen that how these oxygens, whether it is from carbonyl or from ether, that forming this ylite and then different type of reactions are happening. In some cases it is going like a cycloadditions, in some cases it is going as a for the different type of sigma tropic rearrangement reactions. Now, we will see that how this sulfonium ylide that can form. Okay. So, now what we will see the corresponding sulfonium ylide. Okay. Here also similar like oxygen or other nucleophiles. So, sulfur that can attack to the corresponding carbenoid to generate the carbon sulfur bond and to form this sulfonium ylide. Okay. And that can also again proceed various different type of reactions. As per example, we take this thiophene, substituted thiophene, and in presence of these diazoester and rhodium 2 acetate as the transition metal catalyst, then it will form the stable ylide Okay. So, here I would like to mention the reference, that is chemical review from there. Okay. So, next in similar way another sulfur containing substrate where sulfur can react in intramolecular way to the carbenoid to form the corresponding cyclic compound. Okay. Here n equals to 0, 1, 2, 3 and in presence of rhodium 2 acetate again. Okay. In similar way, here the diazoester that reacts in intermolecular way, here it will react in intramolecular fashion to provide the corresponding sulfoniamide. Okay. Okay. Next, in another example where recently Wang and co-workers they have reported this work, they have taken this diazo compound where it is flagged with the aryl ring and the ester ring using this thioether under rhodium 2 species. Again it will give the sulfur elite, that is this one. Okay. So, after that the tautomerizations and followed by sigmatropic rearrangement will give the desired product. So, what is the next after tautomerization, what it will give? So, it will give okay. So, once it is having so nicely the 2,3 sigmatropic rearrangement can happen. I have already mentioned what is this 2,3 sigmatropic rearrangement. Okay. So, once this 2,3 sigmatropic rearrangement will happen, this will generate this particular product, this particular substrate. Okay. Once it will give this, then the 1,3 hydride shift, 1,3 hydride shift will give, or the rear aromatizations that will finally give this product. Okay. So, finally, what this will give? So, this is the reactions of these thioether, that here the sulfur that can react as the nucleophile to this metallocarbide species, and once it will react, that will proceed to the after the tautomerizations, that will proceed through 2,3 sigmatropic rearrangement, followed by these rearomatizations will give the final product. Okay. Next, we will see different type of weak insertion reactions. Okay. So far we have seen that how the carbene species can be inserted into a carbon hydrogen bond, or how that as a nucleophile how the carbonyl or the ether or thioether they can react or form ylide, and different type of reactions can happen. So, here oxygen, that is the like normal alcohol, whether that can be also inserted, we will check that one. As per example, if we take this particular substrate, Okay. So, in presence of copper 1 catalyst, that can be inserted to give the cyclic this product. Okay. Here this alcohol OH is getting inserted into the corresponding carbenoid species. Okay. Similarly, when there is the amine, that can be also inserted nicely into the carbenoid species, that is also sufficiently nucleophilic to attack to the carbenoids. So, as per example, if we take this diazo compound as the corresponding precursor of the carbene, then if we take the amine as nucleophile in presence of rhodium 2 acetate, then that amine they can react or they can attack to the carbenoid formed carbenoid metallocarbenoid, and that will give okay. So, now this can be in a ketoenol tautomerism can happen and give this enol form of this keto compound 1,3-diketo compound. Okay. So, what we have learned so far, that different type of insertion reactions are possible with the carbene species, as the carbene species that is electron deficient and highly reactive, they can be inserted in various type of bonds. As per example, it can be inserted into the carbon hydrogen bonds, or it can be inserted into a other nucleophiles also, it can react with other nucleophiles also. As per example, it can react with the ketos, it can react with the ethers, it can react with the thioethers, or it can react with normal alcohol OH group, or even it can react with amines. And with that, thank you very much.